Welcome to this third video in the series in which we're solving each and every question from this Math Term 1 standard exam with code 03024. Now here is question number 21. The greatest number which when divides 1251, 9377, 15628 leaves these three remainders respectively. So a number which divides these numbers means that this number that we're talking about is the divisor. These three here are the dividends, and in each case the remainders you are getting are different. So how we express this mathematically, let's just work with the first one. Suppose this greatest number is n. Then what it means is when I divide 1251, let's write it here on the side. When I divide 1251 by n, I'm going to get some quotient, and my remainder ultimately is going to be 1. Similarly, you can understand the others. So here, if 1251 is not completely divisible by n because it leaves a remainder of 1, then which number will be completely divisible by n? If you did not have this extra that gave you the remainder. So you remove that extra from 1251 to get 1250. This number is definitely divisible by n. Similarly, 9377, when you divide that by n, there's an extra of 2. That's a remainder. So you take that extra away right from the beginning. What you get is then something which is a multiple of n. And then using the same logic on the last one, you know then that 15625 is a multiple of n. So really then n is a factor of all three of these numbers, right? These three new numbers that we wrote. And since we are interested in the greatest factor, we want to find out the HCF. Here you go. Now I want to look at the common prime factors. The only common prime factor among all three of them is 5. So I take 5, yes. With what power? We know that we have to take the smallest power. So the smallest power that we see on 5 is 4. And that means the HCF is 5 to the power 4. You calculate the value of that, it's 625. Question number 22. Which of the following cannot be the probability of an event? Well, we have to know what probability can be then. Well, by definition, probability of any event, P of E, we calculate that by finding out the favorable events, favorable outcomes, divided by the total number of outcomes. Now, the number of favorable outcomes, which is the numerator, is always less than or equal to the denominator, which is what? The total outcomes. Whenever I divide a number which is less than or equal to the denominator, it has to be a fraction less than or equal to 1. Also, it's going to be greater than or equal to 0 because none of these can be negative. You have number of favorable events, right? Number of favorable outcomes, number of total outcomes. That cannot be a negative number. So what we have ultimately is that probability of any event is always between these two numbers. So we have to see which choice here is not between these two values because we have to find what cannot be the probability. Now a quick glance is going to tell you that D is the answer because this is something which is more than 1 since your numerator here is greater than the denominator. Question number 23. The diameter of a car wheel is 42 centimeters. The number of complete revolutions it will make in moving 132 kilometers is what? So you want to find how many complete revolutions will the wheel make in the car moving a total of 132. Well, for that you need to understand what happens in one revolution. In one revolution, the car moves a distance equal to its circumference. Circumference now of a circle is equal to pi d or 2 pi r. Now since I have diameter here, this is what I'm going to use. So in one revolution, the distance traveled is pi times 42. So let me write down here that this is the distance traveled and this is my number of revolutions. So if this is still in centimeters, let's see how we can simplify this. Just take 22 by 7. This cancels out very nicely. 132 centimeters covered each revolution. Now the question is, if the distance is 132 kilometers instead of centimeters, how many revolutions is it going to be? So you can use unitary method here. First of all, you can see how many centimeters this is. This is 1 kilometer, first of all, goes to a meter with 3 zeros, and then a meter goes to centimeter with 2 zeros, like this. So this is 132 times 10 to the power 5 centimeters. Now understand here that if each 132 centimeter had one revolution, then how many 132 centimeters do you have here? You have 10 to the power 5 132 centimeters. So that is the number of revolutions that you're going to have. The correct answer is B. Question 24. If theta is an acute angle, so it's between 0 and 90, tan theta plus cot theta is 2, then we have to find the value of this. First thing here is we can see cot theta is equal to 1 upon tan theta. So this here is tan theta plus 1 upon tan theta equal to 2. You take the LCM, you add it all, you'll have tan theta here, and in the numerator you will have tan square theta plus 1. Now, taking tan theta to the right hand side gives you tan square theta plus 1 is equal to 2 tan theta. Then get them all on one side and you will start seeing an identity. It's a squared plus b squared minus 2ab, which is equal to tan theta minus 1 whole squared, a minus b whole squared, right? Now if the whole square is 0, that means this thing inside is 0. That's going to give you the value of tan theta as 1. Now since theta is an acute angle where this value is 1, theta has to be 45 degrees. Now till here we found the value of theta. Then finally, very easy to find sine theta, cos theta, the cubes, and then add. Well, what is sine 45 degrees? That is 1 upon root 2, and similarly, the value of cos 45 degrees is also 1 upon root 2. So what I want, the cube of each of these first of all, like this, and then to add them. So here, this is going to be 1 upon 2 root 2 plus 1 upon 2 root 2. Then you add these two, it's going to be 2 upon 2 root 2, which is 1 upon root 2. When you rationalize, that is going to be root 2 upon 2. So the correct answer is C. Question 25. The ratio in which the line 3x plus y minus 9 equal to 0 divides the line segment joining these 2 points is what? So there is this line segment whose endpoints I know. I don't have the equation or anything. I have the equation of another line which is going to divide this line segment. So if I give these things names, then this is A and B. So whatever the line segment may look like, A and B, there is this line then that goes through AB so that it cuts it in a certain ratio. And this ratio is what we need to find out. Now let's see. When you read this page from the book, it gives you 2 formulas to find out the point which divides a certain line segment in a certain ratio. Either you say the ratio is m to n, or it is in the ratio k to 1. I'm going to take this second one here. So suppose the ratio in which this line divides my line segment is k to 1, then the coordinates of the point P where this happens, P is basically where they meet, the coordinates of P are these. So focus on this here. Let me write this properly. This is the formula where what is x1, x2, y1, y2? These are the 2 points which form the endpoints of the line segment. So in my case, I know what x1, y1 and x2, y2 are. I'm just going to put those values here. There you go. Now if you simplify this, this is going to be 2k plus 1 upon k plus 1. That's going to be the x coordinate, and the other side is 7k plus 3 upon k plus 1. That is the y coordinate. Now this point, as you see here, lies on both. It lies on the line segment and it lies on the line as well. So because this point lies on the line, it is going to satisfy the equation of the line, right? So I'll put x as 2k plus 1 upon k plus 1, and I will put y as 7k plus 3 upon k plus 1, and then the rest of it stays the same. So this way it satisfies the equation. When you add these, you're going to get 13k plus 6 upon k plus 1 minus 9 equal to 0. Further simplification will give you 13k plus 6 minus 9k minus 9 equal to 0. Get your k's together as 4k and the constants as this. You solve it, k is going to be 3 by 4. So since my ratio was k to 1, it's 3 by 4 to 1. You just multiply 4 on both sides, you're going to get 3 to 4. So the correct answer is C. Question 26. If x minus 1 is a factor of the polynomial px and a plus b is 4, then we have to find the values of a and b. Well, we have to understand the connection between a factor and a zero. So this is a page from your book which talks about quadratic polynomials, but you can extend it to any kind of polynomial. So if alpha and beta are the zeros of any polynomial, then x minus alpha and x minus beta are factors. So just see how alpha goes with x minus alpha, beta goes with x minus beta. So here now, if I have x minus 1 as a factor, what I can say then is that 1 is a zero of px. And what that means now is that p of 1 is equal to 0. So I'll put x as 1 here. This is going to be 1 cubed a times 1 squared plus 2b equal to 0. When you simplify this, you're going to get a plus 2b is equal to minus 1. And the other relationship you already have in the question like this, you eliminate your a, so you're going to get b is equal to minus 5. Now b equal to minus 5 is only in choice B, you don't need to go on. Question 27. If a and b are two co-prime numbers, then a cube and b cube are what? Now what is co-prime? Two numbers are co-prime if they have no common factors other than 1. Every number has 1 anyway, they're just not going to have anything else. For example, 2 and 5 or 4 and 7. These are co-prime. Now, if a and b already have nothing in common, then will a cube and b cube have anything in common? Think about it. A cube is just a times a times a. B cube is b times b times b. When a and b themselves have nothing in common, how can a have anything in common when I give it 3 b's to the other side? If it doesn't have anything with 1 b, then it will not have no matter how many b's I have. So there is still going to be nothing common between these two. The answer is A. The numbers are still co-prime. Question 28. The area of a square that can be inscribed in a circle of area this much is what? So this is where I've shown a square inscribed in a circle. Now the area of the circle is this. Now the area of any circle is pi r squared, where r is the radius. So first thing I really have here is that pi r squared is equal to this much. Now when I put in the value of pi as 22 by 7, I will already be able to cancel the 7 on both sides. It will give me r squared as 64, and that'll mean my r is equal to 8. It cannot be negative 8 because radius is not negative, it's a length. Now here I'm interested in the square, so I have to be able to connect the square with the circle. You see this diagonal of the square that I've drawn? It is also the diameter of the circle, so the center of the circle is somewhere here. Now what that means is that if this is 8 because the radius is 8, so the diagonal of the square is 16. Now I can get the side of the square from that. How? Just see, this is a square of side s. The diagonal, if you use Pythagoras theorem, it will come out to be s root 2. So for us then, s root 2 is equal to 16. That can tell you that the side of the square is 16 upon root 2. And so the area of the square, which is s squared, as you see here in the book, this is 16 upon root 2 times 16 upon root 2. That's 256 upon 2, which is 128. So the correct answer is C. Question 29. ABC, 3 vertices are given for a triangle ABC. We want to tell what kind of a triangle it is. So we can quickly find out the lengths of each of these sides, AB, BC and AC, using the distance formula, which was also used in another question in the exam. So just pause the video and then play it again to see the formula applied. Here you go, here are the three lengths. Now, is it equilateral? No, all sides are not equal, so this is out. Is it isosceles? Are even two sides equal? No. Is it right angled or isosceles right angled? Well, again, for isosceles, two sides have to be equal, which is not happening here. The only choice left is this. You don't even need to check. Question 30. If alpha and beta are the zeros of this quadratic polynomial px, then the value of k, if alpha plus beta is equal to alpha beta by 2, is what? So basically, I need to find out the value of k. Now, let's see what you have here in the book. What do they teach about this? Well, they've taught you that if alpha beta are the zeros of any quadratic polynomial, then the sum of its zeros, that is sum of alpha and beta, is minus b by a, and the product is c by a. So here then I can find alpha plus beta minus b by a. So first of all, you put a minus, this is your b, and your a is 1. So alpha plus beta is k plus 6. Product, which is c by a, is going to be 2 times 2k minus 1 upon 1. So this is what it stays. Now with this, let me number this 1 and 2. I can put both of these here because this is precisely what I have. See, this is the sum. This is the product divided by 2. So put them here. You're going to get k plus 6 is equal to 2 times 2k minus 1 upon 2. This becomes k plus 6 is 2k minus 1, and then very simple calculation to give you k as 7. So the correct answer is B.